Very good evening. Very good evening. I hope that everyone, am I audible? Just to let me know, am I audible? Namaskaram, Suswagatam, Jubale Sonihal, Sasrikal, Walaikum Salam, Assalamu Alaikum. Welcome, Wanakam, Suswagatam to each and every one of you. This is your Baba HSP Magical Chemistry Group at your Unacademy NEET English channel. Now, first of all, everyone do let me know, am I perfectly audible and visible to each and everyone? Because if I'm perfectly audible and visible, my dear friends, I want to see green signal in the chat section. Let me see the chat. One green signal is there, and that is indicating that yes, everything is fit and fine. But no, my dear friends, very less green hearts are there. If I'm perfectly audible and visible, my dear friends, I want to see some fire in the chat section, green hearts. Let me see what they are writing, because whatever you are writing, I can't see that. What the symbols, emojis are clearly visible, my dear friends. So yeah, number of green hearts and thumbs up. Welcome. Really warm welcome to each and everyone. Today, what I'm going to tell you, kids, here I'm going to tell you inductive effect. And then, my dear students, after telling you this inductive effect, all the tricks, I will give number of questions. Mark my words, my dear students, each and every question will come in your examination from here only, whatever I'm going to give you. Whatever the type of question, exactly those questions are expected for your exam. So remember that inductive effect along with questions. Then after completing all 5 type of trends of the questions, I will teach hyperconjugation. And after teaching you this hyperconjugation tricks and whatever the things, I will give you concepts. I think that this much is the chart, the chocolate plan for each and everything what I'm going to tell you today. So kids, with lot of hard work, I have done number of things in my mind. They are there at the back of my mind, which I'm going to give you today. So everyone, are you ready? If yes, I want to see some fire, and let me see what kids are writing in the chat. Sahana, wow. Doctor, good evening. Deepti, Sanjana, everyone. Now, my dear friends, this is your Baba HSP. Now, I will go from the scratch to the first rank, right? Can you see me? What I'm talking to you, what I'm telling you, are you able to understand? Let me mark my words. This is from my side. Whatever I'm going to tell you, I will tell you from the very beginning, from the scratch, step by step. I will tell you each and everything. I'm not going to skip even a single word, kids. And I'm not going to leave anything, any concept. I will let you know each and everything. Ready? Okay. So the things in your organic chemistry which are looking like idiyappam, muruku, I will really make it nalla eriku. Then you will never say chemistry, organic chemistry pedikkaradu customer. You will always say it's romba sulvam. So that day will come. Whatever I said in Tamil, let me translate in Hindi or English. Better to translate in English. In the starting, the organic chemistry things which are looking really tough, like jalebi type, the mixed things, they will become super easy. I'm going to do that. Now see, without taking your too much time, let me start with inductive effect. Now, what is inductive effect? Let's see what is the meaning of inductive effect, my dear students. Let's see what is the meaning of inductive effect. To understand this effect, just take your copy. Take your copy, everyone. You must be with your pen and copy. Take your copy, everyone, and mark it. Means with applying some little bit of force, mark your pen like this. Hit it. Hit your copy. Copy's page. Hit it vertically upside down. Have you done that? Once you have done that, now see, turn out the page, the first page. At the back of that page, just see where you hit, you applied the force. The page must have come out a little bit out of sight, but page is along with the page only. It has not gone out of the page. It is there. And if you see the second page, it is also having some mark. It is going little bit outside. But this effect is less than the earlier one. Now you see the third page, the effect is either vanished or it has decreased. It's happening, it's happening, it's happening. If it is happening, then show me some green hearts or fire in the chat section. So what I'm going to tell you, there is carbon, there is one more 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 carbon. Carbon, carbon, bro, bro. Carbon, carbon, bro, bro. Until and unless the Bhabhi has not come. Bhabhi, you know, Bhaiya has got married. Now Bhaiya got married. Now this is Bhabhi ji, halogen. Halogen being more electronegative. More electronegative. And it is pulling the electrons towards that side, and the one who is pulling out electron, the electron withdrawing group will get negative charge, delta negative, partial negative, and the Bhaiya which got married, he will start crying, yo, I'm losing my electron, so will get partial positive charge. Now this brother will ask for some money from with this brother. It's like this, and the charge we will take, it got finished up to third carbon. So generally some books are writing it is valid up to second carbon, some are writing up to third carbon, some are writing up to fourth carbon. So in chemistry, you know, you had applied the force, somebody's force is applied up to the fourth page, someone's is applied up to second page, and someone's applied up to third page. So they have taken mean of this, and now this is valid up to third carbon atom. This is clear. So this is covalent bond. I would like to say that inductive effect is valid. Inductive, so assertion and reasoning questions will come. Inductive effect is applicable only in covalent compounds, covalent bonds, and that covalent bonds, it is moving through sigma bond. It is operating through what? Through sigma bond. Sigma bond. Now in an inductive effect, electron is migrating, moving through the sigma bond towards more electronegative atom, but it's not leaving its shell. It is remaining in its particular shell. It is slightly displaced. Remember that electron is slightly displaced. What I'm saying, slightly displaced. If by chance electron has gone completely outside the orbit, like NaCl, number of times examiner is going to ask, in NaCl who is minus I? Tell me in the chat section, in NaCl who is minus I? This is salt. In this salt, who is minus I. Till now I haven't told you who is minus I, who is plus I, but the examiner is asking who is minus I. Write down in the chat section, let me see who is minus I. People will write chloride is minus I, but remember that, my dear students, this is ionic bond. And in ionic bond, inductive effect doesn't take place because electron is completely transferred. Completely, once the completely transferred, my dear students, we will not say it is inductive effect. Not applicable. Who is not applicable, kids? Inductive effect is not applicable. Third carbon atom. Now if anyone is writing like this, drawing compound like this, this is halogen like chlorine, so inductive effect will be valid up to. This halogen's inductive effect will be valid up to. It will be valid only up to which carbon? 1, 2, 3. So maximum effect will be which carbon? So if I say with respect to this is ortho, this is meta, this is para. So we will say inductive effect is maximum at ortho, then meta, and least at para. This is the inductive effect order. It is maximum at ortho, then meta, then para. Till now, it's everything clear to each and everyone. Now see, kids. There are electron withdrawing groups. We will say minus I. Why we will say minus I, electron withdrawing group? Because they are withdrawing electron. So whatever the electrons they were having, the electron will get add up, and that's why they will get partial negative charge. So minus I. Electron donating group will be known as plus I. They are donating electrons, so they will develop partial positive charge, and hydrogen is said to be, its inductive effect is 0 on a standard scale. Now if anyone is asking how many types of inductive effects are there, one minus I, second plus I, they are donating electron, and this is neither withdrawing nor donating electron. Till now it's clear to each and everyone, kids. It's clear. Now see, let me show you the power. Of minus I. There are different types of minus I. Now how to learn it? See, there are different types of minus I. I will say new friend positive charge. Remember that, positive charge. New friend, this valency will be 3 valency and positive charge because 4 valency is there. New friend Narayan, along with Shahrukh, not 3, it's 2, along with Shahrukh and Neha. Kids, got it? New friend Narayan along with Shahrukh and Neha. This point is clear? If yes, do let me know. This order is clear. All the nitrogens, they are having positive charge. Remember this type, when the nitrogen, all the nitrogen, they are having positive charge. This is having maximum minus I. What is the trick? Everyone say along with me. New friend Narayan, new friend Narayan, along with Shahrukh, and Dr. Neha, plus sign, Dr. Neha. This order is clear because this is going to play a very, very important role. If yes, kids, your liking trick, at least appreciate your Baba. Let me see in the chat section what you're writing. You are getting it or not? Then only you will be able to solve questions, kids. Wow, Kiran Pathak, thank you. Let me see the chat section, kids. Let me see the chat section. Everyone say, new friend Narayan, along with Shahrukh and Neha. Now kids, see, The second one. Everyone just see the second one. Naughty Salman. Naughty Salman. SO3H is Salman. Naughty Salman in Rancho's car. Naughty Salman in Rancho's car. Car with carboxylic acid. This is second one. Little bit less than those. Little bit less than those. How? Because these are not having positive charge. They were having positive charge. The one who is having positive charge, that becomes too much electronegative. Kids, that becomes too much electronegative. Now, what is the trick for this? Naughty Salman in Rancho, Three Idiots, Rancho's car, carboxylic acid, carboxylic acid. Everyone got it? Let me see you are able to get it or not. Everyone do let me know in the chat section you are getting it or not. Naughty Salman in Rancho's car. Now, after this is the first group, this is the second group. Now remember that COR, aldehyde ketones, COR, then halogens. In halogens, what you will say? Halogens: fluoride, chloride, bromide, iodide. Then OR, then hydroxy, OR, then hydroxy. Remember that this is the third one. And after that, NH2, phenyl, and then hydrogen. This is the order. If you remember this order, you can solve any question. Till now it's clear to each and everyone. Show me some thumbs up if it is clear. This order is clear and you have this in your mind. Are you able to learn it, kids? Then only you will be able to. R means alkyl group. Nitesh, R means alkyl group. Yes. Everyone just to let me know this order is in your brain or not. Show me some thumbs ups. Everyone hit the like button, kids. Smash the like button. Everyone, wow. Dear Ames, welcome. I'm teaching from basic only. Gajala Mohan Reddy, I'm just teaching from basics. Kids, you have to do what I'm telling you. Yes, now see the plus I. Everyone just see, focus on plus I. This I'm teaching from the very beginning. Plus I. Plus I means electron donating group. Electron donating groups. Electron donating groups. They will donate electron. Now see, who will donate easily? The one who is having negative charge. Remember my words. The one who is having negative charge, that wants to decrease the charge. Because charge is, or you can say stability is inversely proportional to charge. Once the stability is inversely proportional to charge, everyone wants to decrease their charge because they need stability, and to gain stability they don't want to have charge. So the charge one will donate electrons. Now who will donate electron most easily? Now see, kids, if I say the charge is on O negative, and before O negative I can say it is the charge on carbon negative. So the carbon negative will donate its electron easily because negative charge is the least stable on least electronegative atom. After this, I will say NH2 negative or NH negative I can write. After this, O negative, and after this, COO negative. Now you will say why CO negative? Because it is stabilized by resonance. The one who is stabilized by resonance, that will not easily lose its charge because it is saying I am getting stabilized by resonance. So remember that. Remember one point, the one who is being negatively charged will lose its electron quickly, fastly. Now after this, remember one thing, my dear students, more the number of alkyl groups, more the number of alkyl groups, more the number of alkyl groups, more will be plus I, more will be plus I. Now what I'm going to tell you kids, just see this point. If I say the carbon which is attached with 3 methyl groups, so it will have maximum plus I. Then the carbon which is having just 2 methyl groups, this is isopropyl. This is being tertiary butyl kids. Tert butyl means tertiary butyl. This is being isopropyl, and there is ethyl, but in ethyl, let me tell you, CH3 less than this will be CH2CD3. Remember that, CH2CD3. And after that, tritium will have less than this. Now people must ask, why sir, why it is like that? Why tritium is having least? Kids, this is all due to isotopic effect, hyperconjugation. Isotopic effect, that is due to plus H, hyperconjugation. And after that, who will lie? The CT3. Now you will say, sir, it got changed. Why it got changed? I will tell you kids later on that here CT3, CD3, CH3 only plus I, and this I will explain what's the reason is there. There is no hyperconjugation. So this is all about plus I. Now if this is clear, we can solve any question. Now I'm going to move towards questions, but in the chat section, वालेकुम सलाम अस्सलाम वालेकुम, लिटिल कृष्णन पाठक जी, सबको समझ में आ रहा है किड्स? बच्चा पार्टी, just to let me know. Kids, one thing is there. This is YouTube. You know, this is YouTube. Last one is not visible. Okay, let me see. It is visible. I can see in the screen. Oh, this one is not visible. You are right. This one is not visible. You want to say this? This one is not visible. Don't worry, kids. Your Baba HSP is over here, so no need to have fear. When Baba is here, just see CH2 CD D D CH2 CT T tritium T and T. Now I think it's visible. Protium, deuterium, tritium, they are the isotopes. Now kids, let me tell you what is carbocation, what is carbon, and what is free radical. Then we can do all the questions. Till now it's okay, till now. But remember that, kids, it's a YouTube. You know that whenever we are teaching on YouTube, sometimes you're coming, sometimes you're going. That is not going to give you the best thing. Kids, promise me, first of all, if I'm just thinking about whether students are there or they are moving here and there, then how I will teach? First, mark my words and promise, make a promise, the stable one, right? That you are going to sit continuously for 2 hours, at least 2 hours. I will give you a small break then. I will take class for 3 hours. Mark my words, I will teach with this energy level only. I will give you a number of questions, number of quizzes, but you have to sit there, you have to understand. I will teach from the scratch, but remember that you have to understand each and every one so that you can solve all the questions. Make that promise. How I will come to know that you are making that promise? Show me green hearts. The heart, green to go, and green hearts that from the inner core of heart you are going to follow it. I want to see green hearts in the chat section, so that this chat section should get filled with green hearts. I want to see that, kids. Baba want to see. It's my promise. Baba is making promise. Baba is doing promise that Baba is going to teach you each and everything, and you will be able to understand each and everything. This is my promise, this is my bond, and this I'm making a great promise, kids. But for that you have to sit, you have to promise. Yeah, very good, very good. I'm happy from the internal core of my heart. That's the good, kids, right? Now see, bond cleavage. Just see the bond cleavage, how the bond is going to break. Cleavage means breaking of bond. It means breaking of bonds, breaking of bond. Now see, if I say this is carbon and it is attached with any element, now this is the sharing, mutual sharing of electron. Hey, mine, this is my electron. That is saying this is mine electron. Everyone, both of them, they are saying mine electron is shared. Now, suppose if I say this is Champa, this is Champa. Kids, this is Champa, and that is Mr. X. Now they have started one business by sharing 1 crore rupees. Mr. X and Champa, both of them started one business by putting 1 crore rupees. Their business was going on. Kids, their business was going on. Are you getting my point, everyone? Now, one day, Mr. X started thinking, hey, what will happen if I take this money? Remember that for Baba, elements are like human beings. Elements are like human beings. An electron is like money. Remember that. I know the money and the people, the story. I know only one thing: money, people, and the business. So they have shared 1 crore rupee, and Mr. X thought that let me snatch this electron. Now Mr. X is getting benefited, and carbon will start crying. Champa will say, oh, my electron, my money has been taken by Mr. X. Now Champa started crying. Champa is crying. Why Champa is crying and why Mr. X is happy? Champa is crying because Champa has lost 1 crore rupees of her 1 crore rupee and 1 crore of the business. Champa is in loss of 2 crore rupees. I'm not saying those 2 crore rupees were belonging to Champa, but Champa has lost 1 crore rupee of herself and 1 crore rupee of the business. Now, Champa is having only 3 valency. Champa's mother said, carbon's mother said, keep 4. Now, carbon is having only 3 type of people in her life and very less amount of money. Vanna, Renda, Monu, Nala, Anche, Are, only 6 electrons. Only 6 electrons. So octet is incomplete. Now Champa is in need of money. In need of money. Or I can say Champa is crying for money, and Champa is electrophile. Can I say electrophile? Electron seeking, electron loving Champa. Now, this is a society. In one society, Champa's electron somebody has snatched. Now, Champa called her sister. Sister, my money has been snatched by X. Now, remember that if somebody is attached with you, you snatch Mr. X money. So in another compound, my dear students, let me tell you in another compound. So I will draw this Champa once again, and this is known as heterolytic cleavage. What I will say? Hetero means somebody got benefited. Heterolytic bond fission, heterolytic bond fission. Now what else, what other thing can happen? See, the same carbon is there, means Champa is there, same Mr. X is there. Now this time Champa will snatch Mr. X money and will say, hey, just go away. You snatched my sister's money, now have snatched your money. So Champa is now benefited. How many electrons in the Champa's outermost orbit? 1, 2, 3, 4, 5, 6 and 7, 8. 8 electrons. But Champa is not looking very happy. Why? Champa started crying. Hey, I have lost someone. Now Mr. X is not in my life. My mother said, make 4 valency stable. I've got money, but I lost one person from my life. Kids, money is not only the important thing, person also important. So this is known as carbanion. Everyone say carbanion, and that was what? This one was carbocation. Everyone say carbocation, and carbocation is also known as carbonium ion, carbocation or carbonium ion, and this is carbanion. And Mr. X is now crying. This is also your heterolytic fission or cleavage of bond. Heterolytic fission. Fission means breaking of bond. Now, what is the third option which can happen? Now, the third thing is that they decided to get separated. Neither Mr. X nor Champa is going to snatch anyone's money. They will say, let's get separated. This is homolysis. So they will form free radical. They will form free radical formation, and this will be the free radical formation. Till now it's everyone, it's clear. The bond fission you are able to understand. Kiran Pathak ji, maja aaya? Everyone just do let me know. Champa is my favorite. Karan, Kiran, everyone. This way you're liking the Champa, the money, unequal breakage. Yes. Wow, kids, you are liking it or not? First of all, do let me know. In this way everyone is able to understand or not. If yes, I want to see some fire in the chat section, kids. I want to see some fire in the chat section so that Baba can understand, kids. Fire, green hearts, fire. Baba wanna see, kids. That's really fantastic. Now see, applications. Now Baba is going to tell you the applications. See, Baba, let's see. La la la. Give me some sunshine, give me some rays, give me another chance, I wanna grow up again. Champa, cham. Now see, applications, kids, applications. I will tell you 5 applications of inductive effect. Now kids, first let me tell you the most important thing. Before I start applications, I will tell you 5 applications. How many applications? Just to let me know how many applications. Total 5 applications. But before that, you have to answer one thing. If I say this is Champa, hey Champa, this is Champa, Champa. Now, if I say this Champa is suffering with the diabetes, diabetic Champa. Now in chemistry, diabetic means having negative charge. Now this champa is suffering with kwashiorkor and marasmus. Kwashiorkor and marasmus means protein energy malnutrition. That is plus charge. Less money plus charge, more money diabetic, and this is champa. Champa X, champa Y, champa Z. Which champa is more stable? Champa X, champa Y, or champa Z? Do let me know. Out of these three champas, which champa is more stable? Then only you will understand chemistry. One champa is neutral champa without any disease, and rest two champas are suffering with disease. Do let me know which champa is more stable, kids. I want to see the answer in the chat section. Which champa is being more stable, kids? Fast, fast, fast. Oh, the champa which is more stable, kids. Most stable champa. I am asking most stable champa is. Remember that without disease champa is being more stable. The champa which is not having any disease, this champa is neutral champa without disease. Without disease, this champa is not having any disease. So remember that neutral form of compound is being always more stable, neutral form, than carbanion and then carbocation. So from today, remember that, kids. From today, mark my words, that always remember one thing, kids. Neutral form is always more stable. Neutral form of compound. Neutral form of compound is always more stable than the charged form. Mark my words. Categorically, I am telling you this particular thing. Now see, kids, remember this point. Now, if the compound is having charged form, then who will be more stable? Less is the charge, more will be stability. So I would like to say that stability of compound is inversely proportional to charge. Whether that charge is positive or negative doesn't matter. Less is the charge, more will be stability, kids. Mark my words. I'm telling you this particular thing. Most important thing, $1 million, which holds a lot of weightage. The first thing, neutral form of compound is more stable than charged form, and if it is charged, then charge should be less, because stability is inversely proportional to charge. Remember that. Remember that. Now, before I start explaining anything, just to let me know, the one who is having negative charge, tell me. I want to see the answer. If the one who is having negative charge, this carbon would like to donate its electron or would like to gain, kids. I want to teach in that manner so that you can understand each and everything. This is carbanion. This is carbanion, kids. This carbanion would like to, carbanion is in need of decreasing this charge. This charge is due to extra electron. This charge is due to extra money. I told you electron is like money. I told you I'm taking electron is like money. Now, why this champa got negative charge? Because of more money, more money. So how champa will decrease its disease? This negative charge is disease. How this disease will get decreased? How champa will decrease its disease? Kids, do let me know. Yes, this negative charge is like disease. This negative charge, kids, this negative charge means disease, is like disease. And how this disease is there? Because of this extra electron. This negative charge is due to this negative charge negative charge is due to negative charge is because of my dear students, because of extra electrons. Now you will say, sir, how extra electron? Carbon is having just 8 electrons, but all the 8 electrons are not belonging to this Champa carbon, because this one extra electron she has snatched from Mr. X. This one extra electron is of Mr. X. So how Champa will get stabilized? By donating electron. Champa should donate electron to gain stability. The Champa, this is Champa should donate electron to gain stability. Now kids, will you tell me one thing? Who should be the better friend of this Champa carbon, negative charge? The one who is electron withdrawing or the one who is donating electron? Tell me in the chat section, who will be its friend? The one who is withdrawing electron, taking its electron towards itself side, or donating? Minus I electron withdrawing, plus I electron donating. You know, minus I1 are electron withdrawing groups and plus I are electron donating groups. Now who will be the friend of this carbon ion? Do let me know in the chat section. I want to see who will be the best friend. Friend in need is friend indeed. Who will be the best friend? Minus I. Very good. Everyone got it. This thing, everyone got it. Now remember that I will write one thing. See to it. Carbon ions stability is directly proportional to minus I and inversely proportional to plus I. Now, is this rocket science or very simple? Electron withdrawing group, electron donating group. Do let me know, kids. This is rocket science or simple thing? Is this something very big or very simple? I want to see in the chat section. If very simple, show me some green hearts. If it is very simple, show me some green hearts, kids. And just like this, I would like to say that carbocation are having positive charge. Carbon with positive charge. Now who should be the friend of carbocation? So definitely carbocation's friend will be plus I, and dushman means enemies will be minus I. Minus I will be the enemy and plus I will be the friend. Now see clearly, kids, what I'm going to tell you. Just see to it. Everyone just see to it. What Baba is going to tell you, Baba is going to teach you. This is the friend for Champa, negative charge, and this is being the enemy. And here for carbocation, which is having electron deficient, this was having less electron deficient. So this is the friend and this is the enemy. Now just see on the board and come to the conclusion what I have written for carbon ion and what I have written for carbocation. Just see to it, everyone, just see to it what I have written and try to find out the one who is the friend of carbon ion. The same one is the enemy of carbocation. Can you see? Kids, can you see? The one who was the friend of carbon ion is the enemy of carbocation. Can you see? Can you understand? Do let me know. Hey everyone, just do let me know. Thank you, Sahana. Thank you, billionaire thinking. Yes, the one who is dushman of one is the friend of another one. The one's friend has become enemy of another one. Now see, kids, if you are able to understand this thing, now tell me some more things I want to understand from you people. Then Let's start. If anyone is friend, how he can play his role of friendship? The friend will play the role of friendship. Am I right? How the friend can play the role of friendship? How the friend can play a role of best friendship? Best friendship. I'm giving you options. One thing, the first point, distance factor. The second point I am giving you, number, more in number. And third one I am giving you, power, which is the most important thing, kids, out of these three. Distance, he should be nearest, more in number or less in number, or more powerful or least powerful. I am giving you three options, which is the most important thing for a friend to play the best friendship role, which is the most important thing, kids. All of these very good, all of these, that's really fantastic. But if you see, the friend is millionaire or billionaire, but he's too far and you are suffering with fever, that friend can't do anything. So the most important thing in your life is that the friend should be nearest to you. This means the distance factor is the most important thing, kids. Distance factor is the most important thing. So remember that distance, then more good friends, then more power. Power will come at the last. Remember that. So let me tell you, always when you are in problem, always see D, then N, and then P. D and P, doctor, nurses, and patient. The trick for this is doctor, nurses, and patients. Will you remember it? Doctor, whenever you are in problem, remember that doctors, nurses, and patients. Patients. Is it clear, kids? Whenever the question is tough, you have to apply this and then all the questions will get solved. Now see, kids. Now see to it. Baba is going to tell you each and everything. Are you ready, kids? Now see. The first application. First application. Are you ready for this? Stability of carbon ion. First application of inductive effect. Stability of carbon ion. I will give you questions. Now it's your time. Stability of carbon ion. Question number 1, kids. Are you ready for the question number 1? Kids, ready? Question is, arrange the following. Arrange the following in decreasing order of stability. You have to mark your answers. What marks you are going to get, you have to tell me at the last, okay? I will ask. A, CH3, CH3, CH2 negative. B, CH, Cl, CH2 negative. C, CL, CH2 negative, D, C, CH3, 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 CH2 negative. Now I'm not going to give you option for this. I'm in need of answer from your side. Tell me, kids, your time now. Arrange them in the decreasing order of stability. It's your time, kids. Yes, kids. D, then A. I'm waiting for your answer, kids. DACB. Kiran is going for DACB, kids. Your time. I will give you a number of questions. And let me check who is going to give the correct answer, kids. CBAD. Vasu is going for CBAD. Very good. Vasu, you are 100% correct. CBAD. Tamil, Jeevan, Bhavani, CBAD. That's really fantastic. I got it, kids. Now see. This is having negative charge. So chlorine is withdrawing electron. So withdrawing electron. So they all are applying minus I. Three friends. All together they are withdrawing electron withdrawing group. So this disease decreased 3 much. This charge decreased 3 much. So stability increased 3 much. Now here two friends, minus I the friend, two friends kids. So charge decreased too much, stability increased too much. Now these are the enemies. Two enemies, they will donate electron and they will increase the charge. Disease will get increased. Now three enemies, plus I is enemy for carbon ion. They will increase charge too much. So who is having least charge? The least charge is C. After C, B, C, B. Then two enemies, A. Now three enemies, D. How many of you got it? This is the stability order, kids. Decrease in order. How many of you got it? Just show me some. Yes, no, or fire. Now only came. Thank you, Thamil. You have given really awesome answer. Now are you ready for? Thank you, Sukhdev. Thank you. Now everyone ready for another question? You are ready for another question? Do let me know, kids. Kids, everyone do let me know. Are you ready for another question? Now see question number 2. Question is the same. Arrange the following in decreasing order of decreasing, sign of decreasing. This is decreasing order of stability. Right, kids? Now if I say one, 2, 3, 4. AB 1, 2, 3. I want to save your time, my time, kids, so that we can do more questions. So I have one plan in my brain. Brain. Just see what I'm going to decide. See, if I write here A, if I write here B, if I write here C, if I write here D, right? Now if I put negative charge at this place. This is CH2 negative everywhere. So this is the common format I made, kids. CH2 negative. Now I can change the group, so our time will get saved, right? Can you see, kids? Everyone, is it visible to all of you? Is it visible to each and everyone, kids? Now see, let me copy it. Let me copy it. Now see, kids. So if I say that I'm having here, if I add at this place 2 chlorines. Now first easy question, otherwise you will not be able to understand. 1 chlorine, 1 fluorine, 1 NO2 and 1 methyl. Then can you tell me the order? Now the ball is in your court, kids. The ball is in your court. Help me. What should be the answer, kids? Tell me the answer for this question. Everyone, do let me know. Let's see how many of you can do it. Everyone. Do let me know, kids. Do let me know. What's your answer? Fast. Asha is going for B, C, A, D. Let's see whether this answer is right or not. Now see, for carbon ion, this is the enemy. Agreed or not? Everyone agreed or not? This is the enemy. For carbon ion, this is enemy. This is enemy. Here is enemy. First, let's see enemy. Why enemy? This is plus I. Plus I is the enemy. So it is going to withdraw the electron. It is going to withdraw, sorry, it is not going to withdraw, it is going to donate. That's why it is enemy. So this electron will transfer over here, so the charge will increase. Now this is friend, this is friend, this is friend. From there, that see the distance. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All they are at the same distance. All they are only 1. So D is not followed, number is not followed. Out of D and P, D is not followed, number is not followed, only power is followed, and this is the best friend. Most powerful of minus I, most powerful minus I. So it will withdraw maximum electrons, maximum electrons, maximum electrons, maximum. So charge will decrease too much or 3 much. Here out of these, this is good friend. Charge will decrease too much, and here charge will decrease 1 much. So which one is having least charge? B is having least charge. After B, C, after C, A, and at the last D. How many of you got it, kids? Do let me know. How many of you got this answer, kids? Do let me know. B, C, A, D. This is the stability order. Show me some thumbs up. Show me some thumbs up, kids, if you got it. I want to see the chat section that everyone is getting it. Everyone is able to understand or not. Kids, do let me know. Fast, fast, fast. Quick, quick, quick. I will give you those type of questions also. I will give you each and every type of question. But first of all, do let me know you are able to understand. Now Baba is going to give you another question. Just see. Tough question. Baba is going to give you tough question. Just see to it. Everyone just see. If I put here 2 chlorines, and if I put here 1 chlorine only, 1 chlorine, Baba is going to make tough question. Now if I put here 3 chlorines, 3 chlorines, now if I don't put there, now tell me what should be the answer. This is rank deciding question. This is going to be the rank deciding question, kids. Very good, kids. That's really awesome. Wow, that's really fantastic. Now tell me, kids, everyone, do let me know what should be your answer. Everyone, do let me know what's your answer. This is the brilliant question, kids. Brilliant question. B, A, C, D. Vasu is going for B, C A D. Vasu, I think Vasu. Let's see whether Vasu's answer is right or not. Now see, follow DNP. Everyone, you have to follow what? DNP, doctor, nurses and patient. Who will get preference? Doctor. Now see, who is nearest? This is the charge entity. Who is nearest? This is the enemy. Leave it. This is the enemy plus I. This is going to be least stable. Leave it. This is going to be least stable. Leave that. Now here, the friend minus I. Friend is at which carbon? Nearest to it. Just nearest to it. So distance is the least. So the best friend. My dear Kuti Chetan, best friend. Now 1, 2, 3, 4. 2 friends at 4th carbon. And now 1, 2, 3, 4, 5. These are 5, but at 5th position. So after distance, number will come. Number. Distance. Now see, this is at 4th. So distance is less. And that was having least distance. So answer will be B. Then this is at 4th. A. Now this. C. Then at the last D. Gets how many of you got the correct answer? Show me some green hearts if your answer is correct, and fire if your answer gone wrong. Green hearts if your answer is correct, fire if your answer is gone wrong. Kids, green hearts or the fire, do let me know. Distance, number, power rule. Distance, number, power rule. BACD. BACD. Distance, then number, then power rule. Everyone got it, I think. Everyone got it. Everyone got it, kids. Now, kids, the best class is going on. You have to answer it. You have to answer it. You have to answer it. Now, kids. Now another question, just see to it, kids. If I say that I put here 3 methyls, 1 methyl, 2 methyl, 3 methyls. If I put here 3 chlorines, if I put here 2 NO2s, if I put here 2 NO2s, now tell me who is more stable. Who is more stable? Tell me who is being more stable. I want to see the answer. It's fast. Do let me know. What's your answer? Everyone, do let me know. What's your answer? I'm waiting for your answer, kids. Baba is waiting for your answer. Everyone, do let me know what's your answer, kids. Kiran is going for CDBA, Vasu, BDCA. Now let me check it out. What should be the correct answer? Let me check it out. Let me see, kids. Now see, everyone, power same. These are the enemies. So leave them because they are enemy. These are friends. But this is nearest and this is far away. So B, then D, then C, then A. BDCA. Gets right or not? This is the correct answer. Now after carbanion, Baba is going to give you one question of carbocation. Are you ready? Carbocation stability order. Just see carbocation stability order. So let me frame out this carbocation. The second application is carbocation. I made it carbocation. Everyone see the stability order of carbocation. Second application. Stability of carbocation. Stability of carbocation. Now see, the scene will get changed upside down. It will become upside down. Now see, kids. So if I place here two chlorines, if I place here two methyls, if I place here two NO2s, and if I don't place there anything. Now tell me, let's see whose answer is going to be absolutely correct. Do let me know, kids. Now remember, that is having plus charge. Plus charge means carbocation. It's not carbanion. Remember that. It's having plus charge. That means it's different thing. It's carbocation, kids. Earlier it was carbanion. Now it is carbocation. Do let me know. Do let me know. Sukhdev is going for BDCA. NF3. There is no NF3. Remember that. Here is no NF3. These are carbocations. I want to see your answer, kids. Fast, fast, fast. Do it. Make it out fast, kids. Let me see to it. Everyone. CBAD. Let's see. Let's see, kids. Now, first of all, mark which are friend, which are enemy. For carbocation, this NO2 is friend or enemy. Do let me know. This is friend or enemy for, this is enemy. This is being enemy, powerful enemy, powerful enemy, powerful enemy. Now, this one, smaller enemy, smaller enemy, smaller enemy, A, then D. Agreed or not, kids? Everyone, are you agreed or not? Do let me know. This is the correct answer. Agreed, kids? Are you getting it or not? Do let me know. Now, the thing which I am going to tell you, kids, remember that always when I talk about carbanion, so the carbanion stability order is just reverse of carbocation. This is for your board level or NEET level. Very, very simple questions. Carbanion, that was 3 degree. This is 2 degree carbanion, kids. This is 1 degree carbanion, kids. And this is methyl carbanion. So remember that this is 3 degree carbanion. This is 2 degree carbanion. This is ethyl 1 degree. This is methyl 1 degree. The stability order is like this. Remember that. Remember that. Mark my words, kids. This is for carbanion. The stability order for carbanion, kids. Now the reverse will be the stability order of carbocation. How I will write? CH3, CH3, positive CH3. This is tertiary butyl, most stable. CH3, CH plus, CH3, 2 degree carbocation, then ethyl carbocation, kids. And at last methyl carbocation, methyl. So here the order of stability will get changed. Tertiary is more stable than secondary and then primary. So this is 3 degree, 3 degree, then 2 degree, then 1 degree ethyl, then super 1 degree methyl. This is the stability order for this, kids. Remember this. Now, the stability order of carbocation, the same stability here for the simplest one is for free radical also. The same order they will follow. They are having 7 electrons in the outermost orbit. So this one, then this one, then this one. Now last, this one, last but not the least. This is the order of free radical stability. Mark my words, kids. Now what I've told you, this is for carbanion, this is for carbocation, kids, and this is for free radicals. I hope this is clear to all of you, kids. Do let me know in the chat section you got it or not. Everyone do let me know. Then I will tell you for acidic and basic strength. You're liking it. You are getting something new, kids. Everyone agreed. Sahana, Kiran Pathak, all my dear friends. First of all, do let me know. One's name is methyl, ethyl, isopropyl, tertiary butyl. Remember, these names holds a hell lot of weightage. These names are very, very important. Nandini, no problem. Your answer will come in the right way, right manner. Just wait. Now, Baba is going to teach you acidic strength, the fourth application. Ready? Do my swagatam with green hearts. Everyone, if you're ready, Baba want to see the green hearts. Swagatam, welcome with green hearts. Everyone, if you're following my rules. Now see, kids. Acidic strength, which holds a whole lot of weightage. Acidic strength. Now see, kids, acidic strength. Now suppose if I write R, C double bond O, OH. Now, if I ask, this is carboxylic acid. This is being carboxylic acid. Now, my dear friends, if I ask one question, burning question, why this is acid? Everyone will say this is acid because it can release proton. But my dear friend, that is wrong answer. Once it is going to release its proton, it will become charged, and the charge entity is less stable than the neutral form. Remember, my dear students, remember this is neutral form, and that is being charged form. This is being charged form. Baba will change your brain. Baba will give you the truth. The thing which you are missing all the time, Baba is going to give you that thing, kids. Wow, thank you for green hearts, everyone. Really thanks. Baba is going to give you that thing which is actually true. And you are missing that thing, kids. Now see, kids. Actually, this is the water. Water is being proton snatcher. Water is being what? Proton snatcher. It will take away its proton. Now, once the water is going to snatch its proton, it will try to regain back its proton, and that's why their equilibrium lies. This compound, this carboxylic acid, was not in a mood to donate proton, but water has snatched its electrons and got converted into H3O plus. So organic acids are weak acids. They will lie in the equilibrium. They will go forward direction. They will come in the backward direction. They will move like this. Now this is known as acid. And once after donating its proton, it's the conjugate base. Now, the one whose conjugate base is more stable, it can easily lose its proton. Say, if I say this is jacket, the winter season is going on, this is H is jacket. The one who can live, can tolerate that winter season, can tolerate that coldness, will leave its jacket easily, and this is snatcher. Snatcher of jacket. Jacket snatcher. Jacket snatcher, kids. Thus, this is jacket's nature. What is jacket's nature? The one who can live without jacket can lose its jacket easily. Otherwise, the one who cannot live without jacket is not going to go away with his jacket. Now see, or I can say the one whose conjugate base is more stable is more acidic. So I can write acidic strength. I can write like this: acidic strength of an acid. Acidic strength of an acid is directly proportional to stability of conjugate base. Am I right, kids? Stability of conjugate base. Acidic strength of an acid is directly proportional to stability of conjugate base. The one whose conjugate base is stable, that acid can release its proton more easily. The one whose conjugate base is stable, that acid can release its proton most easily. Agreed or not? First of all, tell me. Most easily. This point is clear. This point I have written like this. If this is clear, Baba is going to give you the questions. Baba and you will solve really amazing lecture. Thank you. Thank you. Nandini, really thank you. Now, see. First, I will solve one question for you and then I will ask the same from your side. Now, see, this is for you, kids. This Baba is solving for you, kids. Now, see to it. One is CH3 COOH, acetic acid, the vinegar. Another one is formic acid, HCOOH. And another one is nitroacetic acid. Nitroacetic acid. Now I have drawn three acids. 1, 2, 3. Let me write down their names. Acetic acid, formic acid, nitroacetic acid, now kids, these are acids. Once they have donated their proton or water has snatched their proton, they will become what? Conjugate base. Am I right or not? Absolutely, sir. You're right. 100% correct. What is the snatcher of their proton? Once they have lost their proton, they will become conjugate base. This conjugate base. This one conjugate base. And this one conjugate base, kids. Am I right? Am I making sense? All these are conjugate bases. Right, kids? Acid, conjugate base. This is being acid. That is being conjugate base. Now, kids, just apply inductive effect. This methyl is saying, hey, dear, my dear, what I am going to do? I will donate electron because I am being plus I. I am being plus I will donate electrons and I will increase your charge. I am going to increase your charge. Now the conjugate base charge is getting increased, my dear friends. Do let me know once the charge is getting increased, stability will decrease. Stability will decrease. Am I right or not? Now hydrogen is saying, hey, I'm to neither electron donating nor electron withdrawing. I'm not going to do anything. My inductive effect is 0. Now this NO2 is saying, hey, I'm your friend. I'm minus I, I'm electron withdrawing group. I withdraw electron. I'm taking electrons, so I'm electron withdrawing, so I will decrease your charge. Now see kids, stability will increase. Now can you tell me, my dear students, which conjugate base is being more stable? So 100% this is being most stable conjugate base. Give me the answer. Third is most acidic. Answer is 3, then 2, then 1. Is this clear to each and everyone? This is the acidic strength order. I want to see your response in the chat section. If it is clear or not, the first one, then only I can give you questions, kids. Whatever I taught you, whatever I have explained, if you liked it, at least smash the like button, kids. Right now 148 likes. If you're liking it, if you're loving it, I want to see more likes, kids. If you're really enjoying it, I want to see green hearts fire in the chat section if you're really enjoying it, kids. Little Cupid, super teaching, Dikshita, thank you, Nandini, cleared. Now how many of you are new, kids? Write down in the chat section if you are new, and write down what amazing things you are getting over here. Any new thing you are getting right now at this platform, kids. Write down those who are new and what new thing is getting over here. I want to see, kids, those who are new and what new things they are getting over here. Those who don't know who is Baba, let me tell you, Baba has produced #1 ranked number of times. I've done my M.Tech in 2004, MSc 1999 gold medalist, JRF GATE, teaching for the last 26 years, kids. Jeevan Saktiwal, oh, that's great. Muhammad Semula, concept getting cleared. Wow, thank you, kids, thank you. Now, should I give you amazing session? Should I give you questions now? Should I give you questions now, kids? Questions based on acidic strength. Now Baba is going to give you a number of questions based on acidic strength. Thank you, Dikshita. Thank you. Now see, kids, thank you very much. Now question is, arrange the following in decreasing order of acidic strength. Right, kids? So once again, let me make one format so that you can solve any question immediately. Let me try to save your time. Okay. Now see, if I put here COO negative, COO negative, COO negative, COO negative, and if I write down A, B, C, D. Okay, let me copy it so that I can save your time. So let me start from here. First one, if I write here NO2, if I write here NO2, if I write here two NO2s, and if I put here 2 chlorine, now tell me which is maximum acidic. I want to see arrange in decreasing order, everyone. I want to see your answer kits arrange in decreasing order. Thank you, Divya, Bhatula, Nandini, Chaitanya, Sukhdev. Everyone do let me know what's your answer. Jeevan is going with A, B, C, D. A, B, C, D. Dikshita is also going correct answer kids. Absolutely correct. Absolutely correct. This is the nearest. They all are friends. Friends, all they are friends. Minus I is friend. Now maximum people must be thinking why minus I is friend. The one who is having negative charge. So remember that. Who is the friend of acid? So I will say acidic strength, they are having negative charge. So acidic strength is directly proportional to minus I and inversely proportional to plus I. Minus I are the friends and plus I is the enemy for acidic strength. So friend is nearest in this. Friend is nearest. Nearest. So which rule I will apply? We have to apply doctor, nurses and patients. First we will see the distance of the friend. So A nearest, then B, then they are at equal distance, so number is also same, power of minus I of NO2. So C, then D. I hope that everyone is getting this point. Everyone's answer is coming like this only. So let's move towards another question. So if I put here 2 methyls, CH3, CH3. If I put here 2 chlorines, if I put here 1 NO2, and they are nothing. Now I want to see the answer from your side kids. What's your answer? This time let's see who is going to give the correct answer. Let me check it out. Who will give the correct answer kids? Wow, Sahana, thank you. No problem, Kiran Pathak, don't worry. So the answer is coming. Somebody is writing DCBA, some are writing CDAB, CDBA, CDAB. Now let's see CDBA or CDAB. That's the thing, kids. Let me check it out. What should be the correct answer? Just see, kids. First, try to find out who is the enemy. This methyl group, for this they are plus I, and plus I is being the enemy. Am I right? Am I right or not? Plus I means enemy. 2 enemies are there. Enemy, friend, and this is alkyl group, so enemy. Smaller enemy, they are more in numbers, so big enemy. More in numbers, so big enemy. These are friend, and this friend is nearest, so D and P. Always follow D and P. This is more powerful. Power is more powerful, but what's the problem? It's at more distance. 1, 2, 3, 4th carbon, and this is 2 in number and nearest, so distance is less, number is more, so winner C, then D, then this is having extra enemies, so B, and then A. Kids, got it? This is the correct answer. How many of you got the correct answer? How many you got wrong answer? Show me. Green hearts for correct, fire for wrong. Fire for wrong, green hearts for the correct one. How B is enemy? Let me tell you one question I have seen in the chat section, how this is enemy. Just see, this is alkyl group. CH3, you see, CH3, CH2, CH2, CH2. This is alkyl group, and this alkyl groups are taken as enemy. I think this clear. And this is minus I here, 2 minus I. Now it's clear. Whenever there is simple alkyl group, that is going to be treated as enemy, kids. Now I can see maximum of green hearts, fire. Now see, kids, another question. If I place here chlorine, if I place here NO2, if I place here NO2, now if I place here 1 methyl, and if I place here 2 chlorines, now check what's your answer. Now check it out, what's your answer, kids? Let me see what you're writing for the answer. Thank you Sahana, Chahat, Nandini. Everyone, it will not be mentioned, Parvitika. It's alkyl group. We have to understand that's alkyl group. DBAC, T, right? Sahana, your answer, it will start with the D. Now let me check it out. Kids, Imam, Jeevan, Sukhdev, Vasu, BDAC. Now let's see. No, first we have to see what? See, its power is more powerful. This is more powerful. More powerful friend. Less powerful. But kids, just see, we have to follow what? Doctor, nurses and patient, D and P. First we have to see the distance. 1, 2. It is on second carbon. 1, 2. It is also in second carbon. So this is null and void. Its number is 2. 2 friends. Here 2 friends. Can you see, kids? 2 friends. That is only 1. Who is winner? Only 1 is going to win. Number is more important. More the number of friends win. So D is winner. D. After D, B. After B, A. And this is the enemy. This is the enemy. Enemy. This was the friend. Weakest friend. 1 in number, FRIEND, friend. So DBAC. Kids, got it? Agreed or not? You liked my explanation? First of all, do let me know. You liked my explanation? Everyone, do let me know in the chat section. You liked it? What the explanation Baba has given? You liked my explanation or not, kids? Very good, kids. Very good. Very good. Now, kids, let's have a very small break. Tea break. Can we have tea break? Let's meet after very X-Star Gamer. Thank you, kids. No problem. Now after 15 minutes, we will start after 15 minutes at 8. Now it's 20:42, 9:05. We will start at 9:05, right? Oh, Chahat, thank you, thank you, thank you, Chahat. That's really so nice. So let's see the short break. Right, kids? Right, right, right. We will start with basic strength. We will start with few questions, then basic strength, and after basic strength, we will move towards hyperconjugation. After completing this, I will let you know hyperconjugation, right, kids? Welcome back again, kids. How is everyone? So let's start with basic strength and then hyperconjugation. First of all, everyone, do let me know, can you hear me? Can you see me? Am I audible and visible? Everyone, just do let me know. Am I audible and visible? The fifth application is the basic strength. Show me some fire and green hearts in the chat section if Baba is audible and visible to each and every one of you, kids. So let's start with the basic strength. We'll come to this, but first, let me start with the basic strength, kids. Now let's see. The basic strength. Are you ready, kids? If you can hear me, can you see me? Then show me some fire and green hearts in the chat section. If I'm audible and visible to all, that's really fantastic. Real fantastic. Thank you, kids. Thank you. Now, fifth application is the basic strength. Basic strength. Now, kids, who is the base? Do let me know who is the base. Base means any entity which can donate its lone pair, which can donate its lone pair. Now, if any entity is donating lone pair, then that entity will donate its lone pair to whom? Definitely the proton, because proton is in need of that lone pair. For example, if I write like this is the compound and it is having lone pair and it is going to donate its lone pair to this entity, then they will form a bond like this. Now I will say the 5 valencies is here. So let me remove this one. Now it's okay, kids. Now I will say this is a base. And this is its conjugate acid. Now after the donation of proton, the conjugate base, that means basic strength is directly proportional how easily the entity is donating its lone pair, or how easily that entity is accepting H plus to form more stable conjugate base. This is, conjugate acid. So I can say basic strength is directly proportional to the stability of conjugate acid. Am I right, kids? Now, kids, the only way to understand whether you are able to understand or not is the emojis. Once it is clear, always keep on showing some fire in the chat section. That will indicate that it's clear. Some fire in the chat section that will indicate it's clear. Now, my dear friends, keeping all these things in our brain, keeping all these things in all these points in our brain, let me tell you, let me explain it, what I'm going to tell you, kids. Now, thank you, Kiran, Thamil, Sahana, all my dear friends. Really, you are very, very wonderful, kids, the future doctor and engineers. Now, see, kids, if I say that basic strength in air, basic strength in air, basic strength in air, then definitely I can say one thing, kids. What's that? the thing is that basic strength in air is directly proportional to the plus I. Nothing else, nothing more than that is directly proportional to plus I. Why plus I? I will tell you, kids. So if I say this is nitrogen and it is attached with 3 methyl groups, I would like to say this is trimethylamine, kids, trimethylamine. I would like to say this is dimethylamine, right, kids? Dimethylamine. And I will say this is methylamine, agreed? And this is ammonia. Now just see to it. All they are having their one lone pair. Now this methyl is saying, hey my dear, you just take my electrons also. They all are donating through plus I. All the 3 alkyl groups, they are continuously donating electrons. So this electron density is maximum or not? So kids, you're not able to understand what is the meaning of electron density. I will say this nitrogen is maximum electron rich or not. Do let me know. This nitrogen is maximum electron rich or not? Then the answer will be yes, sir. This nitrogen is maximum electron rich and this nitrogen is least electron rich. Now the nitrogen which is maximum electron rich can easily donate electron. This can easily donate electron. So this is maximum basic. So the basic strength is in this order, my dear students. Agreed or not? That 3 degree amine is most basic. After 3 degree amine, this is 2 degree amine. After 2 degree, it is 1 degree amine and then ammonia. But I'm telling you once again, this is the basic strength in gaseous phase, air, or I can say gaseous phase, gaseous phase. Is this clear? Is it clear to each and every? But when we are going to compare the basic strength in aqueous state, or even the state is not mentioned, remember that the same thing. If I say I'm going to compare basic strength in aqueous medium, basic strength in aqueous medium, kids, or remember that, or when medium is not mentioned, take it aqueous, take it aqueous, consider it aqueous. So the order will come like this: 2, 1, 3, ammonia. But this order is valid only when R is methyl. This is valid when R is methyl. Once R is ethyl, remember that if R is ethyl, then the order will turn out to be 2 degree, then 3 degree, then 1 degree, then ammonia. Now kids, just see to it. When R is methyl, this order is valid. When R is ethyl, this order is valid, and this is experimentally determined. Remember that this is being experimentally determined. Both the two orders are experimentally determined. Let me see, kids, what you are doing. You are able to understand or not? Kids, are you getting it? And thanks for loving your Baba HSP. I would like to say thanks, really thanks for loving Baba's teaching. Now, kids, what I was telling you, that this is being experimentally determined. This order is being experimentally determined. Experimentally determined. Let me write down. Experimentally determined order. Now, how to remember it? Just see, remember it. How to learn it? This methyl is small. This methyl is small. And this ethyl is big. Can you get it? Now see, 2 and 2 is common. Ammonia and ammonia is common. Only the difference is over here. Only the difference is at this place. This is 13 and this is 31. So you just see, kids. Just see to it. Smaller number is 13. 13 is smaller number and methyl is smaller. Now 31 is bigger number and ethyl is also bigger. Big for big. Bigger number. And the smaller number. For small, smaller number. For big, bigger number. Now I will tell you the reasons. I will explain each and everything. I will tell you the reasons. But first of all, do let me know how is the trick. Trick is working or not. If this trick is nalla iruku, means fantastic, super fantastic. If you're liking this awesome trick, do let me know in the chat section that trick is really awesome. I want to see, then only Baba will give you more tricks like this. Do let me know, kids. Kids, what happened? What happened? Now see how this order has come and who is responsible. Now Baba is going to explain. Baba is going to give you the reasons. Just see the reasons. A reason for it. There are 3 reasons. 3 reasons. Reason number 1, kids. Inductive effect. Inductive effect says my vote is, if anyone is going to follow me, my vote is that 3 degrees should be most basic, then 2 degree, then 1 degree, then ammonia. My vote is like this because 3 degree is maximum electron rich, so I will vote for 3 degree. Just like in country, somebody is giving vote to any party and to another party like this, but who is going to win, that is being decided by the final result, and that is experimentally determined. We cannot say whatever we are talking, number of people are talking, that's just the talk of the town. Now see, second factor is steric factor. Steric factor. What is steric factor? Let me explain that. First, let me tell you what a steric factor says. This says my order is just reverse of it. I will give my vote for ammonia, just opposite to this. Now, this steric factor is saying why I am saying like this. I have got explanation to this. According to me, ammonia is least sterically hindered. So the proton can come and attack very easily, although it is having least electron density, but attack is easy. He's just talking about attack is easy. It's not. Attack is easy. Why the attack is easy? Because it's least sterically hindered. Means the hydrogens are very, very small. So no obstacle is there. Least sterically hindered. What is the meaning of this least sterically hindered, kids? That means approach of attack is easy. There is no one. Now if we talk about nitrogen with 3 methyl groups, so obstacles are there like this. Too much sterically hindered. Now proton cannot come and attack easily, so The attack is tough because too much overcrowding is there. They are occupying space. They are occupying space. So they are like this. They are occupying a space like this. They are occupying a space like this. So the approach of proton is tough. Attack is tough here. Are you getting my point? So it's saying my vote is maximum for ammonia. Now who is left? The third one is water. The third one is water, and water says hydration energy. He says my vote HE for hydration energy. So it says my vote is for ammonia. According to me, ammonia should be most basic, then 1 degree, then 2 degree, then 3 degree. Now people asked, how can you say like this? How can you talk like this? Just give reasons how you're talking like this. What is saying? Let's see. Ammonia is there. Ammonia is a base. Water is there. What is the acid in front of this base? Because water is amphoteric, but once ammonia is there in front of ammonia, it will behave as an acid. Getting my point, kids? Now water will release proton, and that proton is going to attack on this ammonia, and ammonia will get converted into ammonium ion, and water will get converted into OH negative ion. Now once ammonium ion is formed, this reaction is in between weak acid, weak base, so it is being definitely a reversible reaction. Now this ammonium is saying, I'm attached with 4 hydrogens, my dear. Now 4 hydrogens, they can attract 4 water molecules like this. 4 water molecules like this, kids, through intermolecular hydrogen bonding. Are you getting my point, kids? Now you know that one ammonium is forming 4 more bonds with hydrogen of oxygen and its hydrogen with water. When the molecules are getting closer, they are releasing energy. More the molecules they are coming nearer, more energy is released. And because this energy is released because of forming hydrogen bonding due to this oxygen, so this is known as hydration energy. So 4 water molecules will release high amount of energy known as hydration energy. Known as what? Hydration energy. So this will release maximum energy. That means this reaction is maximum exothermic. Delta H is negative. Whenever the bond is getting formed, energy is always released. And remember that once the energy is released, it is making this reaction to be maximum exothermic. So all combined together, experimentally, that order has been found. Kids, everyone got it? Just to let me know in the chat section the reason. All 3 they have decided. Everyone got it? Just to let me know, then I will move towards hyperconjugation. Kids, to let me know, everyone, is it clear? Baba is moving towards hyperconjugation with this. Kids, everyone got it? Do let me know in the chat section. So I'm moving towards hyperconjugation. Just see. Now, what are the names for hyperconjugation? What are other names for hyperconjugation? This is very, very important topic, kids. Hyperconjugation. You must have heard this name. Hyperconjugation. Hyperconjugation. What are other names for hyperconjugation, kids? This hyperconjugation is also known as no bond resonance. Remember that, no bond resonance. This is the another name for this. Now, if examiner is asking one more name for this, it is also known as sigma bond resonance. Remember that, sigma bond resonance, kids. Sigma bond resonance. This is also known as sigma pi conjugation. Remember that, sigma pi conjugation. It is studied by and explained by scientists, two scientists. So it is also known as Baker and Nathan effect. Baker and Nathan effect. You will get one question from here only. What are the names for this hyperconjugation? These are the names which are given to hyperconjugation. Now see, kids, what somebody is writing. Let me see. Sahana, free radical stability. I have explained when carbocation, Sahana, when I have given the relation between free carbanion, carbocation, at that time I have given free radical stability, Sahana. Free radical stability I have given at that time. Concluded. Okay, kids, Sahana, clear? At that time. Now see, kids, see here I have shown. Let me show you, Sahana. Just see to it. See, Sahana, this one, free radical stability. I have compared. See, right? Now see, kids. Now if examiner is asking, hyperconjugation is explaining, hyperconjugation explains the stability of. Hyperconjugation question, let me give you. Hyperconjugation explains the stability of first A point, carbocation, B point, alkene, C point, free radicals, D point, all of these. Kids, do let me know. What's your answer? What should be your answer? Hyperconjugation explains the stability of. Do let me know what's your answer. So definitely your answer should be all of these. All of these is the correct answer. And remember that hyperconjugation does not explain the stability of carbanion directly. If I say directly, hyperconjugation doesn't explain stability of carbanions directly. Remember that, directly, kids. Directly it does not deal with the stability of carbanion. Remember that. Why? I will tell you the reason. Okay, I will explain the reason. Now how it is going to explain the stability of carbocation alkene free radical. Are you ready for it? Everyone, are you ready for it? I think the Josh is less, kids. Josh is less. How will you increase your Josh, kids? Drink some water, have some fruits. Only half an hour is more, kids. Yes, very good, very good, very good, Sahana. Yes, yes, yes. Good, 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 good. That's really awesome. That's really awesome. Now see, kids. Very good. Now see, kids, everyone, just see to it. First, let me explain the carbocation stability. First is carbocation stability. Is directly proportional to number of alpha hydrogens. Is directly proportional to number of alpha hydrogen atoms. So remember that more the number of alpha hydrogen atoms, more will be the stability of carbocation. Now how to check alpha hydrogens? Now see, kids, if I say this is carbon positive and the adjacent carbon, if it is sp3 hybridized, this carbocation is sp2 hybridized, so the adjacent carbon is sp3 hybridized and the hydrogen attached is known as alpha hydrogen. This is alpha carbon and this is alpha hydrogen. So remember that more the number of alpha hydrogen atoms, more will be the stability, more will be the stability. Now see, kids, on the basis of this, I will give you one question. Try to solve it. So if I say here is A and A is having this structure, here is B and B is having this structure. Now can you say which one is more stable? The A1 is more stable or the B1? So definitely your answer will be like this. So A is more stable, and I will say, yeah, of course, why not? This is going to be more stable. What's the reason? See, carbon is attached directly with 3 carbons, so all these carbons are alpha carbons, and 3 alpha hydrogens at this place, 3 alpha hydrogens at this place, and 3 alpha hydrogens at this place. All total 9 alpha hydrogen atoms, so 10 hyperconjugative structures. One more. Number of hyperconjugative structures will be one more because one is it is itself. Now how it is going to provide stability, then you will come to know why 10 hyperconjugative structures. Then only you will know. Now 3 and 3, 3 plus 3, 6 alpha hydrogen atoms over here, kids. Now see, kids, how it is going to provide stability. Baba is going to explain that. Now say if I'm saying this is carbon, this is like this, and this is hydrogen. Now kids, there is one theory, number of teachers, number of pupils, they will teach like this. This hydrogen will eliminate out and this negative and positive, they will form bond. In number of books, it's written like this, and then it will come back. But my dear friends, it's better to tell you straightforward the correct thing. The bond is not going to break. What actually happens, you see, this is carbon positive. Once the carbon is positive, it is having this orbital, this is vacant. This is vacant orbital, my dear friend. This is vacant. Remember that this is vacant orbital. Now what is going to happen? The adjacent carbon is having hydrogen. It is rotating due to conformational isomerism, and this is bonded one. This is bonded one. Now carbon and hydrogen, this is having 2.5 electronegativity and its electronegativity is 2.2. So the electron is spending more its time over here, and this will move over there because electron is having particle as well as wavical nature. So it has got the habit of moving, expanding, and this migration from sigma to pure p orbital. Number of times they have asked this question, where to where electron is moving. So electron is moving from sigma bond to pure p orbital, and this is known as molecular orbital theory. Molecular orbital theory. So they can ask this question number of times. In AIMS they have asked. So in carbocations, whenever they are asking for carbocations, then say that carbocation sigma bonded electron moves to pure p orbital, empty orbital. Everyone got it? This point is clear? If yes, show me some green hearts, kids. Let me see, kids, you are able to understand this molecular orbital theory, whether you are getting it or not. Kids, do let me know whether you are able to understand or not this molecular orbital approach. Everyone. Kids, you are taking too much time. Yeah, that's really awesome. Now let's see, kids. Let me tell you stability in alkene. Are you ready? Stability in alkene. What is going to happen in alkene? Oh, this has come. Okay, don't worry, kids. Now see, kids, second point is stability of alkene. This is also, kids, directly proportional to what? Oh, directly proportional to what? Number of alpha hydrogen atoms. Now, kids, in the earlier side, you must be thinking, sir, how number of hyperconjugative structures are one more than? That was skipped. So that is skipped now, kids. That is skipped. So let me tell you that point first of all. Let me tell you that point, kids. See, if I say there is one compound, it is having positive charge, and adjacent to it there is just one alpha hydrogen. If I say there is one alpha hydrogen atom, only one. Now if this hydrogen is going to get removed, it is eliminating out 2.2 electronegativity and 2.5. So this will develop negative and this will develop positive charge. So it will look like this. The new compound will get formed like this. Now, kids, out of this and this compound, they are hyperconjugative structures. So after removal of one alpha hydrogen atom, we have got two. So if there is only one alpha hydrogen atom, so we got two hyperconjugative structures. So whatever the number of alpha hydrogen atoms are there, hyperconjugative structures will be one more than. Suppose if I say I've got three brothers, HSP sir got three brothers. Now how many brothers we are? Three more brothers. That means I'm also the brother of those three. That means we are total four brothers. So hyperconjugative structures is equal to number of alpha hydrogen atoms plus 1. Remember that, plus 1, plus 1, plus 1, one more, right kids? Now stability of alkene is directly proportional to the number of alpha hydrogen atoms. For example, if anyone is giving one question, so why it is directly proportional to number of alpha hydrogen atom? First let me explain this thing, then I will give question. For example, if I say this is CH double bond CH2, and if I say there is one alpha hydrogen atom, so this is alpha hydrogen. So how will you say alpha hydrogen? How to find out alpha hydrogen? This is olefinic bond. Gets double bonded carbon is olefinic bond. And this is sp3 hybridized carbon just attached to this double bonded carbon. This is known as alpha carbon and this is known as alpha hydrogen atom. I think this is clear. First tell me what is alpha. If it is clear, then do let me know that this compound is having how many alpha hydrogen atoms, then only I can explain. This compound is having how many alpha hydrogen atoms? Write down in the chat section. Number of alpha hydrogen atoms in this compound. Do let me know, kids. Then only I can explain. I am going to see in the chat section. Write down. Then only you can understand. And kids, hit the like button. Everyone hit the like button. Smash it out, squeeze it out. Very good. This is indicating that you got it. You got it, kids. You got it. Now, 3 plus 3 plus 3 is 12 alpha hydrogen atoms. Now, what this alpha hydrogen will do, let me tell you on the next page, the molecular theory, the valence bond theory, and then only you will come to know what is going to happen. See, kids. So this is double bond carbon. Anything can be attached over there. This is the pi bond, this is the sigma bond, and here on carbon there is hydrogen. Just see to it. Now kids, this is already filled, pi bond is already filled, so this carbon must be having pi anti-bonding molecular orbital. Pi ABMO. What do you mean by ABMO, kids? Remember that this is brilliant question. Anti-bonding molecular orbital. And once anti-bonding molecular orbital is there, it is being empty, vacant. So this sigma bonded electron, this is sigma bonded, will break. Sigma bond will break and it will convert into pi electron like this, and then it will start doing conjugation with this. So everyone just see in alkene, sigma bonded electron goes into pi anti-bonding star, that is anti-bonding molecular orbital. Now see, this is the molecular orbital theory approach. Now Baba will tell you the balance bond theory approach also. If you're ready, just see the balance bond theory approach Baba is going to tell you. See kids, in the balance bond theory, people explain it like this: CH double bond CH2. Now carbon is attached with this hydrogen. This is being alpha hydrogen. This will break 2.2 electronegativity, so this is more electronegative, so it is going to break and it will look like this. The sigma bond got converted into pi bond or pi electron. Sigma bond got converted to pi electron. Now pi electron will show resonance. It will move here. Let's move here. It will go over there, and due to this situation will get developed. Now kids, neither the first one nor the second one is true structure. The true structure will lie somewhere in between these two, that is known as resonance hybrid. So we will say both of them, they are hyperconjugative structures, and its true structure will be like this, somewhat like this. Get see to it delta negative, partial delta negative, and single bond is getting partial double bond character. Single bond is getting partial double bond character. There is no pure single bond, there is no pure double bond. And how the stability is getting increased? Because if some electrophile is coming to attack on this, and this will start moving, sometimes here, sometimes here, it is moving. If electron is running, it's very tough to attack somebody who is running rather than somebody who is tied up. Tied up will get killed first. So due to delocalization of pi electrons, it becomes tough. For an electrophile to attack on electron easily, and that's why its reactivity gets decreased and its stability increase. And more the number of alpha hydrogens, more will be delocalization. Let me explain it. Let me explain it through one example. Just see to it. If I say that I'm having one compound, all the compounds molecular formula is suppose C6H12. The molecular formula is like this, C6H12. Can see first compound, if I say it's CH2 double bond CH, CH2, 1 2 3 4 5 6 CH3. It is C6H12. The second compound, if I say the second compound is like CH3, CH double bond CH, CH2, CH2 and CH3. If I say I have got third compound is like CH3, double bond CH, CH2, CH3. How many carbons? 3 and 3, 6. Now the last compound, not the least, I have got like this. See to it. CH3, double bond CH3. First of all, you can see all they are C6H12. If I say this is A, this is being B, this is being C, and this is being D, what you will say? How many alpha hydrogens they are having? Then I will show you the magic. The clear picture I will show you, kids. First of all, do let me know how many alpha hydrogens in the sequence they are having, kids. And first of all, I would like to say thanks to each and everyone for giving your time, kids, for understanding, for making yourself to be super awesome students, kids. Really, thank you, Sahana, for each and everything, for studying like pro. Now see, kids, do let me know how many alpha hydrogens they are having, kids. Everyone, now you will say, sir, they are having alpha hydrogens like this. Just see to it. You will say here 2 alpha hydrogen atoms, right? Here 3, here 2. So 3 plus 2, 5 alpha hydrogen atoms in this compound, 2 alpha hydrogens in that compound. Now in this compound you will say 3, 3 and 2. 3 plus 3 plus 2, 8 alpha hydrogen atoms. Now this compound you will say 3, 3, 3, 3. 3 plus 3 plus 3 plus 3, 12 alpha hydrogen atoms. Now see, the stability you got, the stability of this alkene is in this order. That you got clearly. The answer is very much clear. Now see, kids, if I show you how the stability is coming, the resonance or the hyperconjugation is from here to here. This much area it's covering. In this compound, the hyperconjugation is from here to here, more area of delocalization of electrons. In this compound, you will see the hyperconjugation area is from here to here. It is increasing, kids. And the last compound, the hyperconjugation area is from here to here over the entire compound. So see, kids, in which case electrons are getting more delocalization, more space to get delocalized. You just see, kids. Just see, kids. More the delocalization of pi electrons, more will be the stability of compound. One kid is asking how to count the alpha hydrogen. Just see nearest to the double bond, the carbon which is directly attached to double bonded carbon, whatever the number of hydrogens it is holding, they are known as alpha hydrogens. I think this is clear, crystal clear. Now see, kids, Baba is going to tell you the hyperconjugation in free radicals. But before that, you have to solve one question. Just you have to solve one question. Let's see what. Okay, right, kids. Now see, kids. You have to solve this question. Are you ready? Which is more stable? The question is, which is more stable, kids? Question is, most stable alkene. Most stable alkene. Most stable alkene. You have to find out the most stable alkene. A is CH2, double bond CH2. B is CH3, CH double bond CH, CH3. Now C is and D is CH2 double bond CH, CH3. What's your answer, kids? Do let me know the answer in the chat section, everyone. So definitely your answer should be this benzene, because here resonance is taking place. It is stabilized by resonance, not only by hyperconjugation. Stabilized by resonance. This is really awesome thing, kids. Now see, kids, if I have given you another question, just see Another question. Question is most stable alkene. Simple question. Now this time I will give you simple question. Now see kids. Most stable alkene. And now I'm making some structures, just see to it. Structure number 1. Structure number 2. Structure number 3. Structure number D. What's your answer? Let me know the answer in the chat section. Let me check it out, kids. Let me check it out. Answer in the chat section. Yes, kids. Fast. Do let me know. Fast, kids. What's your answer? Fast, kids, fast. Just 15 minutes more. I will complete hyperconjugation. Whatever I have promised, I will complete that thing. Very good. Thamil, your answer is absolutely correct. Thamil. Now see, the answer why it is being correct. Now see to it. Just see to it, kids. If I tell you this carbon and this carbon, this CH3, 3 alpha hydrogen atoms, 3 alpha hydrogen atoms, at this place 2 alpha hydrogen atoms, 2 alpha hydrogen, 3 plus 3, 2 plus 2, 4, 6, 10. 2 plus 2 plus 3 plus 3, 10 alpha hydrogen atoms. Now in this compound, just see, no alpha hydrogen on the right hand side. This carbon, this is attached to, and this is attached to. 2 plus 2, 4 alpha hydrogen atoms. Here, that side nothing. This is double bonded carbon. So at this carbon 2 and at this carbon 2. 2 plus 2. Once again 4 alpha hydrogen atoms. So in this compound, if you see, there is CH3, here is CH2, here also CH2, 2 plus 2, 2 plus 2 plus 3, it's 7 alpha hydrogen atoms. So maximum alpha hydrogen atoms this compound is having. That's why that is being most stable. Now Baba is going to explain the third application, the stability of free radicals. Stability of free radicals. Now see to it, kids. Stability of free radicals. Just see to it, kids. Everyone, are you ready? Stability of free radicals. If I talk about stability of free radicals, kids, that once again is directly proportional to what? Say, stability of free radicals is directly proportional to number of alpha hydrogen atoms. Now let me show you the molecular orbital theory approach, how they will ask the question, kids. See, if I say, even it is drawn in NCERT also, if I say this is your free radical, once I'm saying this is being free radical, there is hydrogen, just see to it. The free radical is having pure p orbital. It is having what? Pure p orbital. Remember that. How will you find out pure p radical? That the one which is not hybridized, that is known as pure p orbital, and this pure p orbital is vacant, empty. Remember that. Pure p orbital, that means that is empty orbital, that is empty orbital. Now this is ready to accept electron because this is vacant. This is vacant, and you know that this carbon is sp2 hybridized. Remember that sp2 hybridized means it is having percentage of s character, that is 33.33%. remember that more is the s character, more is the electronegativity. More s character means, gets more s character means more electronegativity. More electronegativity means, kids, more capturing capacity for electrons. So it is just pulling electron, and this electron will get pulled towards that side. So this is the migration from sigma bonded electron is going to pure p orbital, which is having one electron. So it is going to half filled pure p orbital, that is known as SOMO, singly occupied molecular orbital. What is the full form? Singly occupied molecular orbital. So this is the theory, my dear friend. This is the theory. Now these are the three applications I have told you. Now the fourth application is the orientation. It is going to decide whether the given benzene derivative is ortho-para-diacting or meta-diacting. Are you ready for the fourth one? Show me some green hearts, some fire if you're liking my teaching. I'm telling you simple things and each and everything. First of all, do let me know in the chat section, everyone enjoying my teaching, kids? Kids, do let me know. Baba is Kiran Pathak ji, bas 15 minutes or just 15 minutes more. Baba is teaching you simple, tough, each and everything, kids. Baba is not leaving even a single stone to be unturned, so that, kids, you will get definitely the best rank. Kids, I want to see the Josh in the chat section. Where the Josh is missing, kids? Yes, singly occupied, reverse hyperconjugation. Wow, you know number of things. So make it 200. Make likes to 200. I want to see likes should get 200. Now fourth application. Are you ready for fourth application? Fourth application. See. Fourth application is, kids, ortho and para orientation. Ortho and para orientation. Now what is required? What is required for ortho and para orientation? Remember that what the thing is required for this, that the compound should be like this: benzene, and on benzene this carbon must have at least one alpha hydrogen atom, and this carbon must be sp3 hybridized. What? This carbon should be sp3 hybridized, and at least one alpha hydrogen atom should be there. This is the bare minimum condition. Now how it is ortho-para orientation going to show? This is sp3, so 2.5 electronegativity, and this hydrogen is 2.2, so it will break this bond. Once the bond is going to break, it will look like this. Just see, kids. Bond broken, bond broken, broken bond. Hey, my hydrogen is lost. It will start crying. Where you have gone? Where you have gone? Now the electron will start shouting, I want to move. Let's move, yeah. Let's move, yeah. Let's move, yeah. Let's move, yeah. So it will start moving. It will go towards benzene. Hey, I want to come at this place. This carbon saying, hey, how can I accommodate you? How you can occupy this position? He's saying, hey, just don't fight. You just give force to your pi electron. Your pi electron will go somewhere else. Oh, that's you want to say. Yeah, what I'm telling you, just let's move here. Let's move here. So this electron will come over here and this electron will go over there. Now see what is going to happen. The situation will turn out like this, and this carbon will get negative charge. Can you understand this much? Now the electron will say, hey, now I know how to move. Let's chill, let's chill. It will start dancing. I want to come. I'm being the electron. I know how to come. I will force you to go at that place. Now it's move here. Let's move here. So it will start moving and the electron will come like this. And the electron will occupy this position and this will turn out to be like this. Just see. Now the electron will say, I will not stay back. I'm the electron like wave. I got wavical nature, so I want to move. Let's move here. Let's move here. This will come at this place and this will go over there. This is how the electron is moving over the entire benzene ring. Now once again, see what is going to happen, kids. It will be like this. Now the electron will say, I want to go back. The place from where I have come, I want to go back. Okay, no problem at all, my dear. You want to go back to your house? Yeah, I want. Now, by doing this, by moving this, what it has created, it made history. It made history. So none of the structure they are giving the correct information about. They all are being hyperconjugative structures. Now the one who is going to draw the one and only one structure for all these hyperconjugative structures, that person will say, hey, just summarize it in one structure. What you have done, just tell me in a single structure. So he will say, hey, my lord, hey, my highness, I have gone to ortho, I have gone to para, then I have gone to ortho. That means जग घूमिया थारे जैसा न कोई. In Hindi song there is, I've traveled a lot to the whole holy places, but I made this thing. So sometimes here single bond, sometimes here double bond character I have created. So I have increased the benzene's electron density. I made benzene to be more electron rich. So everyone started asking, you increase the electron density on which carbons? He's saying, hey, you don't know? I have increased the electron density to OP. Are, what is this OP? Are, he is saying OP is ortho and para. So the ortho and para carbon, they have become more electron rich. This is ortho, this is ortho, and that is para. So whatever the electrophile is going to come, it will attack at ortho and para positions. So my name is not Anthony Gonzalez. My name is ortho para directing. So it is saying I'm the ortho and para directing. If anyone is going to do or want to show ESR, so toluene will show ESR. So if any electrophile is going to attack on this toluene, then that will attack on what? Hey, I will come and attack at ortho as well as at the para, because both the carbons are more electron rich. So I will form two types of products, ortho derivative, para derivative. Two types of products will be formed by me. You got it, kids? So this is known as ortho and para director. Why ortho and para director? Because he is the director of the house. This is the guest. Now guest will not decide on in which room I will stay. This guest is staying in ortho and para, decided by the director of this benzene ring, director, and that's why it is known as ortho and para director. You got it? Kids, this one you got. Then I will tell you reverse hyperconjugation. First of all, tell me everyone, you got this one? Everyone, is it clear? Is it clear? Then I will tell you the fifth application, that is reverse hyperconjugation. Kids, do let me know, is it clear or not? Is it clear or not? Clear. Now see, the application number 5th, Baba is going to explain it. The 5th application number 5th. Are you ready, everyone? With the new color, I will show it. The 5th application. That is the most important, kids. What is that? What is that 5th application? The reverse hyperconjugation. What I'm saying, the reverse hyperconjugation. Everyone say reverse conjugation. This is also known as minus H. People call it on the minus H, reverse hyperconjugation. Now see, kids, if we are having benzene ring and on benzene ring if 3 halogens are attached, how many halogens? 3 halogens, like chlorines. Now who is being more electronegative? So the answer is chlorine's electronegativity is 3.2 or 3.1, and this carbon is 2.75 because sp2 hybridized, and this carbon is 2.5. So definitely now chlorine will say, hey, I will take your electrons. Da, da, da. Carbon started crying. Somebody has stolen my electrons. Now what should I do? Oh, mommy. Now carbon started crying. Kids, it started saying that chlorine has stolen my electrons. Now somebody suggested him, why can't you take electron from this benzene ring? Oh, so nice of you. Thank you for your suggestion. So it has taken electron from that benzene. Now benzene has become less electron rich. Now the pi bond will move. Just move, yeah. This pi bond will come over here. It will give one more resonating structure. Just see, kids. It will form a bond over here. Now the plus charge will come at this. Now see, once again it will move, kids. This will move over there. One more resonating structure, that hyperconjugative structure will get formed, plus charge at this place. Now in this way, if we summarize these structures, that all ortho para, they got positive charge. Are you getting my point, kids? So this is the point to be noted, my lord. All my dear students, this benzene has lost electrons, so this benzene will become electrophilic or still nucleophilic. Do let me know, it will become electrophilic or nucleophilic. So still it will remain nucleophilic, because if somebody is having 6 crore rupees and that person has lost few rupees, then he is not going to become beggar. Still nucleophilic, but its electron density has become less at ortho and para position. Once the electron density has become less at ortho and para position, the meta position is comparatively more electron rich. What I'm telling you, kids, in this, the meta position is still more electron rich, or comparatively more electron rich. Can I write like this? Meta position is comparatively more electron rich. More electron rich. Can I talk like this, kids? So it is meta director. So if I write its equation, if somebody is going to write its ESR, that is electrophilic substitution reaction. So remember, my dear friends, the coming electrophile will attack on its meta position, and it is going to make only one type of product. So E will be at this position, and this is the only one type of product. So this will be known as meta director. Now, my dear friends, the next application is heat of hydrogenation. Have you heard this name? Heat of hydrogenation. Have you ever heard this name? What should be that application number? Tell me, that should be the application number, kids. Application number 6th or 7th? What should I say? This should be the application number. Which application, kids? Do let me know. Which application? Heat of hydrogenation. Now, how will you define what is heat of hydrogenation? Remember that its definition, very, very important definition, kids. The amount of heat released when one mole of alkene gets completely hydrogenated, in the presence of excess of hydrogen. Remember that hydrogen should not be less. This is defined as heat of hydrogenation. I'll call it in short HOHO, heat of hydrogenation. Now here one thing is very, very important. People are doing that mistake. Most important thing I'm going to tell you, what mistake is done by people. They're always thinking that heat of hydrogenation is inversely proportional to number of alpha hydrogen. So the stability of alkene. That is true, but not exactly true. Let me tell you, kids, what mistake is done by most of the kids and why they are, most of the time they are getting failed. Just remember that heat of hydrogenation is directly proportional to number of pi bonds. Remember that. Number of pi bonds. This is $1,000,000 question, kids. And remember that once the number of pi bonds are equal, if the number of pi bonds are equal, then heat of hydrogenation is inversely proportional to stability of alkene. But this is valid only, my dear friends, in one case. That is what? Once the number of pi bonds are equal, once the number of pi bonds are equal, this is valid when number of pi bonds are equal. Now kids, you must ask for the reason. Always see this point first on first number, then come to this point. How many of you are in need of asking reason? Because time is moving very fast. Now let me check whether you are interested in knowing the reason or not. If you are interested, then only Baba will tell you. Otherwise, why? No, why? Then if you're not interested, then why? Baba is going to tell you. If you are interested, then only Baba will tell you the reason. Kids, do let me know. Kiranji is saying ha. Sahana is saying ha. Yes, me. Yes, Baba. See, kids. If I say, remember that one thing, make very clear in your brain. To break the bond, energy is required or released. To break bond, tell me, to break bond, energy is required. When bond is formed, then energy is released. Am I right or wrong? Energy is released. Third point, who is weaker bond? Pi bond is weaker or sigma? Pi bond is weaker. So less energy is required to break this bond. Less energy is required to break it. Sigma bond is strong. So more energy will get released. Am I right, kids? These points are very, very basic points. If these points are clear, then only we can understand anything. Now see, kids. If I say in ethene, there is one pi bond. So energy is required to break this pi bond, and hydrogen will combine with this. So in place of one pi bond, their formation is of how many pi bonds? 2 sigma bonds got formed. By one pi bond has broken, 2 sigma bonds got formed. Stronger bond is getting formed. Pi bond is getting broken up. So less energy is required, more energy is released. Are you getting my point? Required is less. Required energy is less. So released one is more. So overall, whatever the energy is released, that is delta H, known as negative. But if I say the another compound at the same time, if I say this compound is having 2 pi bonds, now how many pi bonds will break? 2 pi bonds will break, and in place of 2 pi bonds, how many new sigma bonds will get formed? Answer it out. How many new sigma bonds are getting formed, kids? Do let me know. So the answer lies 4 new sigma bonds are getting formed. So more the number of bonds are getting formed, then more energy will release, in which case more energy is going to get released. Here delta H is negative, there delta H is negative, both the places delta H is negative, but more amount of energy will get released in the second one because more sigma bonds are getting formed. More sigma bond formation means high amount of energy released. So kids, let me give you one question. Let me explain one question, and that will be the end of this session. Okay, kids? Let me explain one awesome question. Question is, arrange the following. Brilliant question, kids. Arrange the following in decreasing order of heat of hydrogenation. Remember that heat of hydrogenation. Compounds are like this. CH2 double bond CH, CH2, CH double bond CH2. B, CH2 double bond CH, CH double bond CH, CH3. C, CH2 double bond CH, CH2, CH2, CH3. D, CH3, CH double bond CH, CH2, CH3. Kids, this question will require some time, so do it properly. This is the last question of today, kids, today's session. Now kids, answer this question. Let's see who is going to give the correct answer, kids. This is the last question of today's lecture, kids. I taught you each and everything. Thank you, Dikshita. Thank you. Thank you very much. Thank you, Kiran. Thanks, little Cupid. Now tell me, kids. 196. At least make it 200, kids. The likes are 196, 199. Only one like in need of, kids, to make it 200. Okay, definitely, Abuzar Nadvi, because we have to complete it. Make it 200 kids. One like, who is going to give that like kids? Thank you, Kiran. Now CDAB, Medico is going with CDAB, Tamil ACBD. Sahana A. Now C kids. Let's see what should be the answer. Remember that divide and rule. Whenever question is like that, always follow divide and rule. See how to play divide and rule. The two, they are having two pi bonds. Remember that they are having how many pi bonds? Two pi bonds. The last two, they are having just one pi bond. So definitely the heat of hydrogenation will be maximum for either A or B. Now see, in between A and B, these two pi bonds are separated. These two pi bonds are separated by two sigma bonds. There is no resonance. In the first one, there is no resonance. No resonance. Are you getting my point? No resonance. Now see, in the second one, pi, sigma, pi, resonance stabilized. This is being resonance stabilized kids. And once it is resonance stabilized, this is more stable. So kids, out of these two, this is more stable. So this is the winner. So A will have more than B. This is decided. Now here, this is having just two alpha hydrogen atoms. Two alpha hydrogen atoms, and this one is having 3 and 2, 5 alpha hydrogen atoms. So who is winner? C is greater than D. Now if you combine it, the answer will come out what kids? A, B, C, D. So the answer is A, B, C and D. This is the order for heat of hydrogenation. You got it kids? How many of you got it kids? Do let me know how many of you have enjoyed the lecture. So tell me in the comment section. I'm asking one question. The question is, kids, how was the session? You have to write down once this video is over. You have to tell me either Hindi, English, whatever language you want to ask, Tamil, Telugu, whatever the language, Bhojpuri, you have to write down your comments once the video is over. According to that, Baba will take the lectures, will give you the questions, whatever you want more. How was the lecture? Will you do that, kids? So, God bless you, kids. May Almighty God bless you with all happiness and prosperity. Bye to each and everyone. Shubhratri, Shabakhair. Good night. We'll meet you again, right? All the best, kids. All the best. Do proper revision. Direct questions will come from here. Okay.